Welcome to the project demonstration of hybrid power generation grid monitoring through IoT using microcontroller. So in this project we are going to get mainly voltage availability from the sources, and the same data will be stored into the IoT cloud platform, and that will be represented in the graph manner. So here we can see the wind power generation, and that will be plotting here for every 10 seconds of duration. And we can just click on the dot, we can see the how much of voltage got at so-called date and time. Same for the solar panel, and same for the piezoelectric plates. So this is a continuous process until we providing the data along with Wi-Fi hotspot near this cage. And the sources we are going to use is a wind power generation, which can generate 12 volts, maximum of 2 amps of current. Means we are using the 25 watts of generator we are using here. And solar panel we are using 12 volts 3 watts, and piezoelectric plates can generate up to maximum of 15 volts and with less current, as we are using the demonstration purpose these plates. And the output from these three sources is input to this battery pack through these charging circuits. So here we can see these three charging circuits look like same. So each charging circuit consists of DB107 voltage regulator, voltage rectifier, DB107 rectifier, which is a full wave rectifier which will take AC inputs and provide us the DC outputs. But here we are using the three sources or DC sources only. But here the rectifier purpose is when we providing the DC inputs, that will act as a polarity corrector. Means if the wind rotates in either direction or anti-clockwise direction, then the so-called LED will be indicated. We can see that because of this rectifier, it will be rectified. The clockwise rotation of the turbine or counterclockwise rotation of this wind turbine will be rectified. Same for the solar panel also. But coming to the solar panel inputs, if we place the solar panel in reverse connection, so the solar panel output, if we place that in reverse connection, so that it will be rectified. So that's why we are using this of the rectifier as a polarity corrector. And one more thing, if you want to charge a battery pack, whenever the say wind, solar and piezo is not available, with the help of this transformer, just you can disconnect any one of the two pins. Just for demonstration I am removing this, right? So by removing this wind, just connect the transformer over here, and now on the power supply to that. So only connect the transformer over here. Okay, and now the LED indication which will show the status of battery is charging. It will get around 4 hours to 5 hours to be get fully charged. Till the duration the battery keep on charging. And so after the time completion you can disconnect this. And while we are demonstration of the project, the transformer is not part of the project. This is just for safety extra source of charger for the battery. Now connect the battery over here, wind over here, and we are connected these three sources to the microcontroller directly through this voltage sensors, right? So here we have interfaced this to the voltage sensors. Two voltage sensors consist of two resistors which are connected in series, as we are using them as 10:1 voltage ratio. Means whenever the input of this voltage sensor is 12 volts, then the output from this voltage sensor is 1.2 volts. So in the microcontroller we write a logic to multiply that with 10, as we are using the 10:1 voltage ratio. And here we can see that two voltage sensors are placed. Piezo directly interfaces to the microcontroller, as it's providing the low current. So that's why we need to interface directly to the microcontroller. So the interfacing is A0, A1, A2 pins for the respective voltage measuring purpose, and B2 to B7 interface to this PIC microcontroller. B0, B1 for the ESP 8266 Wi-Fi module. It's continuously uploading to the Thingspeak with the help of this ESP 8266 Wi-Fi module. Coming to the battery rating, we are using 12 volt 1 amp battery pack. This battery pack consists of 3 4 volt 1 amp batteries. As we need 12 volts battery, that's why we have connected the 3 4 volt 1 amp batteries in series. So we'll get 12 volt 1 amp DC output from this battery pack. So before demonstration, first of all we need to on the hotspots. So with the help of the hotspot only, the system will upload the data to the Thingspeak. So go to hotspot settings and configure the hotspot name to project 7269 without any space, without any capital letter. Password should be 123456789. AP band should be 2.4 GHz. So after enabling this hotspot on the data and next log into Thingspeak. So this is the Thingspeak. Generally we'll get like this. After you log into Thingspeak, just click on the data. This is a page we're going to get to monitor the data. This can be accessed from anywhere in the world. Okay, so you can erase this data. Before erasing that, you can download the data also. So better download the data before erasing. For that, data import export. Download the data and it will get downloaded in Excel sheet format. You can access it directly by opening that in Excel sheet. So it will consist of date and time along with date and time along with how many samples till now collected. Around 61 samples we have collected, and first one is, as we discussed, the wind voltage and solar voltage, and next piezo voltage. So these are the data we have downloaded from the Excel Thingspeak. After you got the download data, then go to channel settings. Channel settings to clear the channel. So in that, only do clear the channel. Don't delete the channel. So only clear the channel. After channel got cleared successfully, right, now go to private view. Okay, so see, the whole data got erased. Now on the power supply to the switch, by switch on the battery pad, just on that. Okay, below is the on. Right, welcome message displayed on the LCD screen. Piezo voltage and solar voltage continuously displayed. Right, we got the data. Now solar as 1.64 volts, just click on that, we'll get the data. And piezo 0.17 and wind 0 volts. Okay, so just we want to do that. Okay, yeah, right. You can see the wind is generating the voltage, right? Okay, any of the direction, it rotates. You can see the light indication on the wind turbine charging station, right? So it's a continuous process till we disable the Wi-Fi or switch off the kit. Just by placing the more lighting on the solar panel, so we are getting the voltage more. Right, 2.11 is coming the voltage from this one. Okay, so in this manner, so the hybrid voltage monitoring will be possible through the IoT technology. And as we discussed, this can be data read and download the data from anywhere in the world. Thank you. Yeah, so here I forgot to mention the load also. So here we are using this grid application purpose, that is DC load. We have interfaced that to the system for utilization purpose. Thank you.